Question 1, you can see, deals with a pair of right-angled triangles, and question 2 does not. So let's have a go at question 1. They want us to work out the size of angle P, which is this angle here. And if we look out from that angle, we're clearly not interested in the opposite side. So any of the sock and toe relationships that contain an opposite are out. So is out and so is TOA. So we must be using the cosine relationship. And my recommendation is you write down the cosine relationship based on this angle P. So I can say that cos P is equal to the adjacent over the hypotenuse. This is clearly the hypotenuse because it's opposite the right angle. So this is 2.8 divided by 3.5. Now, as the calculator normally gives us the cosine for an angle, and here we want the angle for a cosine value, we need to use the cos to the minus 1 feature of the calculator. So all I've got to do is find cos to the minus 1 of this particular fraction. And the answer I get for P is that P is equal to 36.8698 degrees. It would be stupid to quote that number of figures given that we're only up to 1 decimal place on our input. So I would suggest the answer truncated to 1 decimal place would also be 36.9 degrees, and that's to 1 dp. And that is your answer. Okay, part B. So we need to find KL, and we know the size of this angle down here. So be that angle for the moment, and if you look out, opposite you is KL, and this must be the adjacent because the hypotenuse is not needed. So yet again, in our relationship of SOHCAHTOA, anything with an H in can be disregarded, and this time we're going to need TOA, and let's call this side X. Okay, so tan 51 degrees is equal to the opposite X over 10.5. Therefore, so without doing anything in the calculator, just rearrange and get X on its own. X is equal to 10.5 multiplied by the tan of 51 degrees. And if you look that up on a calculator, you get, which, as they've asked us to truncate the number to 3 significant figures, means our break will be there. And because we've got 664, which we're cutting off, we have to round this number up. And it turns out that this is 13.0, and this is to 3 significant figures. Okay, let's have a look at the second question. As we spotted already, this is not a right-angled triangle, so we have to use either the sine rule or the cosine rule. Now, what can we use? Well, actually, we can use the sine rule because we've got a side-angle pair. We know the side and we know the angle. And it looks like we're going to have to go via this relationship here because the final relationship we know nothing about. We don't know this side and we don't know this angle, so we can use this middle relationship to find this angle and then use the fact that all the angles in the triangle add up to 180 degrees and find the angle which we actually want, which is this guy down here. Okay, let's quote that sine rule. So what have we got here? Let's call this length C, this is length A, and this is length B. Here's the relationship we know everything about. So we can start by writing that down. In the sine of 63 degrees divided by its opposite length of 8.1 is equal to, this is the relationship we're now going to use, and this is the angle we're going to use. We can say that sine, it's an angle we don't know, so we just use sine A divided by its opposite length, which is 6.3. A little bit of rearranging the furniture involving the cross multiplication of these two numbers here. Sine A remains on the top, and I'm going to swap sides. So sine A is equal to sine 63 degrees over 8.1, and we're going to multiply that by 6.3. If we pop that into a calculator, we get that A is equal to, now we've got angle A and we've got this angle C down here. We need to calculate the angle that we want, which is ABC. So therefore, angle ABC C is equal to 180 degrees minus 63 minus our angle A up here, and this turns out to be 73.13154, which, if like the previous question we quote to three significant figures, we get 73.1, and that is your answer.